The next way we can simplify radicals is by rationalizing the denominator. So in simplest form, we just don't leave a radical in the denominator. To be perfectly honest, this is kind of an old method of simplifying. Before they had calculators, it was easier to evaluate if the radical was in the numerator. Now we do it just because it's simplest form. So let's go ahead and see how this works for our simplest form. To get the radical out of the denominator, you want to multiply by the radical when it's just a single value like we've got in part A. Make sure that you multiply by fancy form of 1. If you are not multiplying the expression by 1, you are changing its value. And we're not changing the value, we're just changing what it looks like. So square root of 7 divided by itself is 1. So the expression will look different, but it will be equal to what we started with. Multiplying straight across, we've got 3 times the square root of 7 in our numerator, and the radicals cancel in the denominator, just like we saw in the last video with the square root of 6 times the square root of 6. So we're left with just 7 on this one. I also want to teach you a shortcut for getting these simplified. What happens when and this works when you've got a single radical in the denominator like what we have here. If you look at part B, it's a complex radical. This trick does not work. So please understand when the shortcut works and when you got to do the work. So notice how the square root of 7 moved up to the numerator with the 3 that was already there, and the 7 without the radical stayed in the denominator. So real quickly, to show you another way using the shortcut, if we had 4 divided by the square root of 5, move the radical to the numerator and drop the radical, leaving the value in the denominator. That's the quick way to get it rationalized. If that makes sense to you, otherwise feel free to continue doing it the long way like what I showed you on part A there. All right, part B, again, this does not work to do the shortcut, so we do have to do the work on this one. And the fancy form of 1 that we need when we have a complex denominator like this is what's called the conjugate. So you multiply by the denominator, but switch that sign. Again, multiplying by something over itself is that fancy form of 1, so we're not changing the value, we're just changing what it looks like. Distribute that 2 in the numerator, so we'll have 2 plus 2 times the square root of 6. And in the denominator, I'm going to show you the long way to do this, and then we'll talk about the shortcut of multiplying conjugates. So we have 1 times 1, which gives us 1. 1 times positive root 6, negative root 6 times 1, and negative root 6 times positive root 6. Those radicals will cancel, but a positive times a negative is negative. What happens when you multiply conjugates is always this. You get 2 of the same thing with opposite signs, which will cancel, leaving us with 1 minus 6. So the shortcut would be, if we had 1 minus root 6 times its conjugate, the shortcut to multiplying conjugates is to simply multiply those first terms and multiply the last terms. This only works for conjugates. If they do not look the same with opposite values, you have to go through and FOIL everything out. All right, so going back to our problem and simplifying, giving myself a little more room here. Numerator is simplified, 2 plus 2 root 6. And in the denominator, 1 minus 6 is negative 5. With fractions, we don't leave a negative in the denominator either, so I'm going to move the negative up to everything in the numerator and drop it in the denominator. Finally, we're going to take a look at some more simplifying, but this time with rational exponents. So these are going back to those exponential rules we learned yesterday, but now it's going to be slightly more complicated throwing those fractional exponents in there. This one, again, we've got a couple of options because of that negative exponent. We can simplify them first or get rid of the negative exponent and then use our simplifying rules. In this case, because the bigger exponent is positive, I'm just going to use our rule for multiplying powers, which is to add the exponents. So we have 4/3 plus negative 2/3, which gives us a 2/3 power. We've got something similar going on with part B. Now notice part B, the base is quite a bit more complicated, but these two powers, here's the first power that I'm referring to, and this is the second power that I'm referring to. Notice they have the same base. The base for each of these powers is 2x to the negative 1. So I can use the same rule that I just used on part A and add those exponents together, the exponents being 4/3 and negative 1/3. So I'm keeping my base 2x to the negative 1, and I'm combining my powers. 4/3 plus negative 1/3 is 3/3, or 1. I've still got a negative exponent in there, that x, so I'm going to flip that to the denominator, and that power is going to become positive as well. For part C, I don't want to deal with a decimal power, I want to deal with a rational exponent. So I'm going to start by turning that into a rational exponent. Remember, the way to convert a decimal to a fraction is to just read it. Using proper notation, don't say 0.2, that's not helpful. Read it with place value. So the place value for this is tenths. So what we have is x to the 2/10 power. So what I'm going to do next is simplify that power as x to the 1/5. This one is using that rule where we have multiple radical signs, so we can multiply the indices together. Remember, this is our first index, 3, and when we don't see an index, it is assumed to be a square root, so we have an index of 2. So multiplying those together, I get a root of 6. Or I could rewrite it as 125 to the 1/6 power. All right, yes, this was a long lesson. There's a lot to learn about radicals, or remind ourselves. Hopefully all of this was review for you and I was jogging your memory and not teaching you anything new. So we've got a couple of you-try problems on this page for you to try.